Download this code from codegive.com, link in the description below. OK, let's dive into unit testing Python code using pytest, a popular and powerful testing framework. This tutorial will cover the basics, best practices, and some more advanced techniques, along with practical code examples. Table of contents *. 1. What is unit testing and why do we need it? 2. Introduction to pytest. 3. Installation and setup. 4. Writing your first test case. 5. Understanding test discovery. 6. Assertions and test outcomes, pass/fail/skip/fail. 7. Fixtures, setting up and tearing down test environments. 8. Parametrization, running the same test with different inputs. 9. Marking and skipping tests. 10. Test doubles, mocks, stubs, and spies. 11. Working with configuration files, pytest.ini or pyproject.toml. 12. Code coverage analysis. 13. Plugins and extending pytest. 14. Best practices for writing maintainable tests. 15. Running tests in parallel. 16. Continuous integration, CI, integration. 17. Advanced topics, if time permits. Hypothesis testing. Using pytest with Django/Flask. 1. What is unit testing and why do we need it? Unit testing is a software testing method where individual units or components of a software application are tested in isolation. A unit is the smallest testable part of an application, which is usually a function, method, or class. Why unit test? Early bug detection. Finding and fixing bugs early in the development cycle is significantly cheaper and easier than debugging them later in production. Improved code quality. Writing unit tests forces you to think carefully about the design of your code, leading to better structured and more maintainable code. Documentation. Tests serve as a form of living documentation, showing how individual components are intended to be used. Refactoring confidence. Unit tests provide a safety net when refactoring code. If the tests still pass after refactoring, you can be confident that you haven't introduced any regressions. Reduced debugging time. When a bug is reported, well-written unit tests can help you quickly pinpoint the source of the problem. Enforced API contracts. Unit tests define and enforce the expected behavior of your code, ensuring that changes don't break existing functionality. 2. Introduction to pytest. Pytest is a popular and powerful Python testing framework that simplifies the process of writing and running tests. It's known for its simplicity, easy to learn and use. Minimal boilerplate code required. Readability. Tests are written in a clear and concise style. Extensibility. A rich ecosystem of plugins extends its functionality. Automatic test discovery. Automatically finds test files and functions. Fixtures. A powerful fixture system for managing test setup and teardown. Parametrization. Easily run the same test with different inputs. Comprehensive reporting. Provides detailed test results and error messages. 3. Installation and setup. Before we start, you need to install pytest. Open your terminal or command prompt and run. Optionally, you can install pytest COV for code coverage analysis. 4. Writing your first test case. Let's create a simple Python module and a corresponding test file. File, my_module.py. File, test_my_module.py. Explanation import statements import pytest, imports the pytest library. Although we don't directly call anything from pytest in this basic example, pytest needs to be imported to run tests. Asterisk from my_module import add, subtract, multiply, divide, imports the functions we want to test from our my_module.py file. Make sure the file is in the same directory, or adjust the import path accordingly. Asterisk test functions asterisk. Asterisk test function names should start with test underscore. Pytest automatically discovers functions that follow this naming convention. Asterisk each test function represents a specific test case. Asterisk assertions asterisk. Asterisk the assert statement is the core of a test. It checks if a condition is true. If the condition is false, the test fails. Asterisk assert add 2, 3, == 5, this asserts that the result of add 2, 3, is equal to 5. Running the tests asterisk. Open your terminal, navigate to the directory containing my_module.py and test_my_module.py, and run. Pytest will discover the test file, test_my_module.py, execute the test functions, and display the results. You'll see output similar to this. This indicates that all 5 tests passed. If any tests failed, pytest would provide more detailed information about the failure, including the assertion that failed and the values involved. 5. Understanding test discovery. Pytest automatically discovers test files and functions using these rules. Asterisk test file naming asterisk pytest looks for files named test_.py or _test.py. Asterisk test function naming asterisk pytest looks for functions named test_ inside test files. Asterisk test class naming asterisk pytest also recognizes test methods within test classes. Test class names should start with test, and test method names should also start with test underscore. Example with test classes asterisk. Running with specific paths asterisk. 6. Assertions and test outcomes, pass/fail/skip/sfail. Pytest uses standard Python assert statements for verifying conditions. Here's a breakdown of test outcomes. Asterisk pass asterisk the assertion evaluates to true. Asterisk fail asterisk the assertion evaluates to false. Asterisk skip asterisk the test is intentionally skipped, example because it's not yet implemented or requires a specific environment. Asterisks fail asterisk expected to fail. The test is known to be failing, and you're marking it as such. If an xfail test passes, it's considered an unexpected success and is reported as spies. Using pytest.raises for expected exceptions asterisk. As you saw in the test_divide_by_0 example, pytest.raises is used to assert that a specific exception is raised within a code block. More assertion techniques asterisk. Pytest integrates well with unitest.testCases assertion methods. While less common in pure pytest style, you can still use them. 7. Fixtures, setting up and tearing down test environments. Fixtures are functions that provide a fixed baseline for tests to reliably execute against. They handle setup and teardown tasks, such as creating temporary files or directories, establishing database connections, mocking external resources, setting up initial application state. Defining fixtures You define fixtures using the @pytest.fixture decorator. Explanation @pytest.fixture decorates the temp_file function, making it a fixture. Yield the yield statement is crucial. The code before the yield is executed during the setup phase before the test runs. The value yielded is what is passed to the test function. The code after the yield is executed during the teardown phase after the test runs. Asterisk using fixtures in tests. Asterisk to use a fixture in a test, simply include the fixture's name as an argument to the test function. Pytest automatically injects the fixture's value. Asterisk teardown. Asterisk the os.remove, file_path, line after the yield handles the cleanup, ensuring that the temporary file is deleted after the test completes. This is essential to prevent leftover files from cluttering your system. Fixture scope. Asterisk. Fixtures can have different scopes, which determine how often they are executed. Asterisk function, default fixture is executed for each test function. Asterisk class. Asterisk fixture is executed once per test class. Asterisk module. Asterisk fixture is executed once per module. Asterisk package. Asterisk fixture is executed once per package. Asterisk session. Asterisk fixture is executed only once per test session. To specify the scope, use the scope argument in the pytest.fixture decorator. Fixture autos. Asterisk. If you want a fixture to be automatically used by all tests in a module, or other scope, you can set autos equals true. 8. Parametrization, running the same test with different inputs. Parametrization allows you to run the same test function multiple times with different sets of input values and expected outputs. This is very useful for testing edge cases and different scenarios. You can use the pytest.mark.parameterize decorator to parameterize tests. Explanation. Asterisk. Asterisk pytest.mark.parameterize, x, y, expected, asterisk. Asterisk. The first argument is a comma-separated string of parameter names, x, y, expected. These are the arguments that will be passed to the test function. Asterisk. The second argument is a list of tuples. Each tuple represents a set of values for the parameters. Asterisk. Test function. Asterisk. Asterisk. The test_add_parameterized function takes the parameters x, y, and expected as arguments. Pytest automatically injects the values from the parameterization. Running the tests. Asterisk. Pytest will run the test_add_parameterized function 4 times, once for each tuple of input values. The output will show each individual test case. If a test case fails, Pytest will show you which set of input values caused the failure. Using IDs for better reporting. Asterisk. You can provide custom IDs for each test case in the parameterized decorator using the IDs argument. Now, the test output will include the custom IDs, making it easier to identify failing test cases. If a test failed, the ID would be shown in the error message. Parameterizing with fixtures. Asterisk. You can also parameterize tests using fixture values. This is useful when you want to run the same test with different setup configurations. Explanation. Asterisk. Asterisk. pytest.fixture, params equals option 1, option 2, asterisk. The params argument in the pytest.fixture decorator specifies the list of values that the fixture will take. Asterisk. Request.param. Asterisk. Inside the fixture function, request.param gives you access to the current parameter value. Asterisk. Test function. Asterisk. The test_with_option function takes the my_option fixture as an argument. Pytest will run the test twice, once for each value in the params list. 9. Marking and skipping tests. Pytest provides markers to add metadata to tests, allowing you to categorize, skip, or modify test behavior. Skipping tests. Asterisk. Use @pytest.mark.skip or @pytest.mark.skip if to skip tests. Expected failures, xfail. Use pytest.mark.xfail to mark tests that are expected to fail. Custom markers asterisk. You can define your own custom markers to categorize tests, example @pytest.mark.slow, @pytest.mark.integration. You need to register custom markers in your pytest.ini or pyproject.toml file. We'll discuss configuration files later. Running tests with specific markers asterisk. You can use the M option to run tests with a specific marker. 10. Test doubles, mocks, stubs, and spies. When testing code that interacts with external systems, databases, APIs, files, etc., you often don't want to actually interact with those systems during testing. Instead, you use test doubles to simulate their behavior. Common types of test doubles include mocks objects that have predefined expectations about how they will be used. You can set up mocks to return specific values, raise exceptions, or verify that certain methods were called with specific arguments. Mocks are used to verify interactions. Stubs objects that provide canned responses to method calls. They are simpler than mocks and don't verify interactions. They are used to replace dependencies. Spies objects that record information about how they were used, example which methods were called, how many times, with what arguments. Spies are often used to verify side effects. Pytest doesn't have built-in mocking capabilities itself, but it works seamlessly with the unitest.mock module, part of the standard library, and the mock library, a third-party alternative, often preferred for older Python versions. We'll use unitest.mock here. Example with unitest.mock asterisk. Let's say we have a function that fetches data from an external API. Now, let's write a test for this function, using a mock to avoid making actual API calls. Explanation asterisk. Asterisk from unitest.mock import patch, mock asterisk imports the necessary tools from unitest.mock. Asterisk at patch, requests.get, asterisk the patch decorator is a context manager that replaces the requests.get function with a mock object during the test. This prevents the test from making real API calls. Asterisk mock, asterisk creates a mock object. You can configure the mock's behavior by setting its attributes and methods. Asterisk mock underscore response.json.return underscore value equals key, value asterisk configures the JSON method of the mock response to return the specified dictionary. Asterisk mock underscore response dot raise underscore for underscore status dot return underscore value equals none asterisk configures the raise underscore for underscore status method to do nothing, simulating a successful response. If we set the side underscore effect, we will raise that error. Asterisk mock underscore get dot assert underscore called underscore once underscore with http://example.com/API, asterisk asserts that the requests.get function, which is now our mock, was called exactly once with the specified URL. This verifies that the get underscore data underscore from underscore API function is using the API correctly. Asterisk side underscore effect asterisk the side underscore effect attribute is used to specify what the mock should do when it's called. In this case, we're raising an HTTP error to simulate an API failure. 11. Working with configuration files, pytest.ini or pyproject.toml. Pytest can be configured using a pytest.ini, tox.ini, or pyproject.toml file in the root directory of your project. This file allows you to customize pytest's behavior, define markers, specify test paths, configure logging, and more. Example pytest.ini Explanation Asterisk adopts asterisk specifies command line options that are always used when running pytest. Asterisk v, verbose output, shows the name of each test. Asterisk -cov equals my_module, enables code coverage reporting for the my_module package. Asterisk -cov report term missing, shows a report in the terminal, highlighting lines that are not covered by tests. Asterisk test paths asterisk specifies the directories where pytest should look for test files. Asterisk markers asterisk defines custom markers that you can use in your tests. Using pyproject.toml, recommended. Pyproject.toml is the standard configuration file for Python projects, and it's the recommended place to configure pytest. 12. Code coverage analysis. Code coverage analysis measures the percentage of your code that is executed by your tests. It helps you identify areas of your code that are not adequately tested. To enable code coverage analysis with pytest, you need to install the pytest.cov plugin, as mentioned earlier. Then, run pytest with the -cov option, specifying the package or module for which you want to measure coverage. This will generate a coverage report in the terminal after the tests have finished. To generate an HTML coverage report, use the -cov report HTML option. This will create an hgov directory containing the HTML report. Open the index.html file in your browser to view the report. 13. Plugins and extending pytest. Pytest has a vast ecosystem of plugins that extend its functionality. Some popular plugins include *pytest Django for testing Django applications. *pytest Flask for testing Flask applications. *pytest BDD for behavior-driven development, BDD. *pytest for running tests in parallel. *pytest mock a convenient plugin for mocking objects, alternative to unitest.mock. *pytest.cov already mentioned, for code coverage analysis. *pytest randomly executes tests in a random order to help uncover hidden dependencies. To install a plugin, use pip. Then, pytest will automatically discover and use the plugin. Refer to the plugin's documentation for specific usage instructions. Writing your own plugins *. You can also write your own pytest plugins to customize its behavior or add new features. This is an advanced topic, but it allows you to tailor pytest to your specific needs. 14. Best practices for writing maintainable tests. Write focused tests each test should test a single aspect of the code. Avoid writing large, complex tests that cover multiple scenarios. Follow the arrange act assert, AAA, pattern arrange set up the test environment, example create objects, configure mocks. Act execute the code under test. Assert verify that the code behaved as expected. Use descriptive test names. Test names should clearly indicate what the test is verifying. Keep tests independent. Tests should not depend on each other. Each test should be able to run in isolation. Use fixtures for setup and teardown. Fixtures help you manage test environments and ensure that tests are reproducible. Avoid hard-coded values. Use constants or fixtures to represent values that are used in multiple tests. Test edge cases and error conditions. Don't just test the happy path. Make sure to test how your code handles invalid input, exceptions, and other unexpected situations. Keep tests up to date. When you change your code, update your tests to reflect the changes. Write tests first, Test-driven development. Consider writing tests before you write the code. This can help you design better code and ensure that it's testable. Use code coverage to guide testing. Code coverage analysis can help you identify areas of your code that are not adequately tested. 15. Running tests in parallel. For large test suites, running tests in parallel can significantly reduce the execution time. You can use the pytest plugin to run tests in parallel. Then, use the N option to specify the number of workers, processes, to use. Pytest will distribute the tests across the worker processes, allowing them to run concurrently. 16. Continuous integration, CI, integration. Continuous integration, CI, is the practice of automatically building and testing your code whenever changes are made. This helps you catch bugs early and ensure that your code is always in a working state. Pytest integrates well with popular CI systems like *GitHub Actions *, *GitLab CI *, *Jenkins *, Travis CI *, Circle CI *. The basic steps for integrating Pytest with a CI system are: 1. Configure your CI system *, create a CI configuration file, example.gethup/workflows/main.yml for GitHub Actions, .gitlab-ci.yml for GitLab CI. 2. Install dependencies * in your CI configuration file, specify the commands to install your project's dependencies, including Pytest and any necessary plugins. 3. Run tests * add a command to run Pytest in your CI configuration file. You can use the adopt setting in your pytest.ini or pyproject.toml file to configure Pytest's behavior. 4. Report results * configure your CI system to report test results. Many CI systems have built-in support for Pytest's test results. Example GitHub Actions Workflow *. 17. Advanced topics, if time permits. Hypothesis testing * using Hypothesis, another Python library, to generate test cases automatically. This is useful for testing properties of your code, rather than specific examples. Using Pytest with Django/Flask * using the Pytest Django or Pytest Flask plugins to test your web applications. These plugins provide fixtures and utilities that are specific to Django and Flask. This comprehensive tutorial should give you a solid foundation for unit testing your Python code with Pytest. Remember to practice and experiment with different techniques to find what works best for your projects. Good luck.